Today I'm going to be making something called Biuret's Reagent, which was created by a guy named Gustav Piotrowski. Biuret's reagent is commonly used as a laboratory reagent to identify proteins in solution. It chelates with copper-2 ions in solution to form this violet color that indicates the presence of proteins. To make this explanation as simple as possible, I'm going to go stepwise in explaining what is going on here. So right here we have an insulin protein molecule, which is a hormone that regulates glucose levels in the blood. So right here on to the right of the protein, you can see an amide group. Now when we add the Biuret's reagent to the protein molecule, which is insulin in this case, theoretically, the alkaline environment causes the hydrogen on the amide group to dissociate from the nitrogen. The dissociated hydrogen neutralizes with the free hydroxide ions in solution to form water. This amide group then chelates with the copper ions in solution to form a violet chelate, which is the violet color that's commonly associated with Biuret reagent tests. So hopefully we can get something that looks like this in color. This test was done with egg albumin, although insulin could theoretically work. For this experiment, I'll be using copper-2 sulfate pentahydrate and hydrous sodium hydroxide, a 50 and 100 milliliter tall form beaker, a low form 50 milliliter beaker, droppers, an egg, and some skewers. I begin by preparing solutions A and B. In solution B is 0.5 grams of copper-2 sulfate pentahydrate. In solution B is 4 grams of sodium hydroxide. In both of these solutions, I mix approximately 50 milliliters of distilled water and dissolve them completely. This creates approximately a 0.04 molar solution of copper-2 sulfate, which is shown in this equation I did above. I also did the calculations for the sodium hydroxide solution, which would yield us about a 2 molar solution of aqueous sodium hydroxide. After both solutions completely dissolve, I first begin by adding solution B first, and then I add solution A afterwards. This is a simple reaction that forms sodium sulfate and copper-2 hydroxide in a double displacement reaction. However, since we added an excess of sodium hydroxide, a complex reaction occurs where excess hydroxide ions complex with copper-2 to form a tetrahydroxydocuprate 2. This quickly forms a very vibrant blue solution. I fill the 50 milliliter beaker with nearly boiling distilled water, and I add 2 dropperfuls to a perfectly intact test tube. I then add a dropperful of the Biuret's reagent that we just made and place it back into the nearly boiling distilled water that's in the 50 milliliter beaker. Then using a skewer to pierce the egg, I miserably fail. After accepting my failure, I break the egg off camera and stick a dropper inside of the egg and suck up approximately 1 milliliter of egg albumin, which is just egg white. You don't necessarily have to use egg white for this, but I'm just using it because it's high in protein. I then add the protein into the test tube. As soon as I add the protein into the test tube, you can already see that the copper is beginning to chelate with the proteins, forming this very purplish solution. It almost looks like Kool-Aid to me, and it's kind of amusing. After about a minute, the solution in the test tube looks like this grape Kool-Aid, which is really cool to me. The egg albumin floats to the bottom while the proteins become aqueous as this purplish solution. I then pour the contents into a 50 milliliter beaker to better show this color. That's pretty much it, and just as a side note, the Biuret's reagent that we made in the other beaker will eventually decompose into copper oxide. You can stabilize this by adding a chelating agent like sodium potassium tartrate, but I find that just works better as is. Anyways, that was pretty much it for the video, and I hope you enjoyed it.